Hey everybody, this is Larry. This is day 16 of the September Leetcode Daily Challenge. Hopefully the sound is better this time. My bad. I didn't check the sound level. This time I think I did. There may be a little bit echo in the room, but hopefully that's okay. Yeah, so I'm still in Lisbon, so stay good. Okay. Hit the like button, hit the subscribe button, join me on Discord, and let's go over today's poem, Spiral Matrix. I usually start this live, so if it's a little bit awkward or whatever, yeah, just watch it on the fastest speed or whatever you need to do. Okay, let's get started. This one, it seems like it is what it sounds like, which is to say super, super annoying. Um, yeah, there are a couple of ways to do it. There are smart ways to do it mathematically. To be honest, to be frank, I'm probably a bad video here in that historically I've been just really bad about it. You can definitely do it in all of one space for sure, but I usually only get these problems during contests, so I'm always under time pressure, meaning that I'm trying to get it out as soon as possible. So I end up using linear space, which is the size of the input. Um, yeah, and today, to be frank, I'm going hiking, so or driving and hiking a little bit, explore the shores of Lisbon. So I am under that time pressure as well. So I'm going to do it in linear space, and of course you cannot do it better than linear time because that's the size of the input. And by linear time, just to clarify for some of us, linear time is r times c because that's the size of the input, right? So yeah, so I think I'm going to do it that way because I just want to get it done. But yeah, I mean, I think this is just really, it's really annoying. To be frank, maybe I need to kind of step back at a certain point and just be like, okay, this is how we do it. I mean, I know how to do it in constant space. You just kind of do. There are a couple of ways to do it. You could do the math and do the for loops and then just like do it that way. There's a way to do it with bounding boxes, but I think it just takes too much time to kind of get it. I mean, not even too much time to implement, but too much time to get it right precisely, right? Because there's just so many off by one possibilities that I'm going to do the way that I'm going to do at least during a contest. During an interview, definitely take as much time as you need, or within reason, obviously, because there's a time. But yeah, that's how I would think about this problem. So I apologize in advance that this is not going to be 100% for space, but hopefully this gets you off at least to begin the problem because it is very thing that I do. But yeah, so the way that I usually do it with or these kind of 3D traversal problems is that I actually just have a Boolean while you're visited. Let's do R is equal to length of matrix and C is equal to length of matrix of 0. Of course, the other thing to look at is they use M and N. I prefer R and C just for row and columns. But yeah, this is 10 by 10, so we don't really have to worry about this kind of stuff. But yeah, this is just Python thing. But yeah, now we have directions, so let's do the directions. Usually the order doesn't matter, but in this case it does, at least the way that I'm thinking about doing it. So now, first of all, we want to go right. So going right is positive y, at least the way that I'm structuring, and then going down is positive x, and then left is negative y, and then up is, yeah, oops, yeah. And then then we can just do, yeah. I mean, there are a couple of ways you can do a loop. And in terms of shortcuts, I would just try to think about different things. I think the one that I'm thinking of right now, I just came up with. I mean, not like in a new way, but I'm like, okay, this work? This will work. So maybe you can do it as well. But yeah, but I would do something like for count is equal to 0, while count is greater than r times c or less than r times c. So I typed the right thing, but I said the wrong thing. But yeah, and then here we do it one at a time, which is that we try to go right as much as we can, then we go down, and then we go left, keeping in mind that in these cases, you cannot, yeah, you cannot do the other steps, right? Meaning that I was just double checking that, make sure. Actually, I was going to be honest. The other reason I paused is because I was going to do it another way. But now that I think about it, there's another invariant that you can see, which is that every cell you always actually want it to go right if you can, but you can't. Oh wait, that's not true because if it's a if it's a 4 by 4 box, there's 9 going up, and then if you try to go right, you go right. So I guess you have to go on you have to set your direction and then set it. Okay. So yeah, so we have a direction that started at 0. Oops, a typo would be nice. But yeah, and then current cxcy is equal to 0, 0. And then, oh yeah, of course, an answer array. What is the, okay, yeah. Okay. And then here we just go, yeah. So answer dot append directions of oops, not that, matrix of cxcy, okay, and then count increment, and then now we do the interesting part for me anyway, maybe. Yeah, and then here we do is if we go in the same direction, will we hit the bounding box, or will we hit outside, I suppose, or a visited cell? So that's cx. Let's just say next x next y is equal to cx plus directions of direction. This is maybe terrible, but that's fine. Let's just do also dx dy is equal to this, and then dx cy plus dy. If if this is within bounds, then we're Gucci, then we're good. Otherwise, we will do direction is equal to direction plus 1, so that we go to the next order. And of course, you have to multiply by 4 to wrap around. I'm trying to think whether there are any cases where you need to do that twice. I think you can always go right? It's almost like going for a maze or something. So yeah, so in this case, if this is within bounds, then you do next door construction is going. So hopefully that doesn't come up. Man, there's a lot of issues with my trip today. But yeah, otherwise you do this thing, and then we do it again, and I think this should be good though, because I don't think you need to do anything else, but I could be wrong. Let's see, we can do an assert here though. We can assert, oh, one more thing that I did forget is that and what was I going to say? And that is not visited, right? So yeah, oops. Visited cx cy or not visited, or nx ny, whoops. And the other thing that I wanted to do with that is we have to mark it as visited, obviously. Man, they're doing construction at 8 a.m., which is kind of intense, to be honest, because I could still be sleeping, just not actually, but you know. We could do an assert here, and this is a common thing that people do, because so that we can, because if this will give a one-time error, or I guess in Python it's not quite that, but yeah, it will give an error in any case if this is false, so that you can kind of assert that this is true, even though it does come obviously with some performance hit, but okay, well, there's some technical difficulties. Okay, so assert is already wrong. That's a little bit sad, but okay. Let's do without it just to see what the error is. I mean, obviously it is just this. Oh, I did this wrong. Oh no, that's not, that part is right. That's weird. I mean, we have the right answer, so okay. So I guess my assert is just has a typo somewhere. If it is assert that it is not visited. Oh, I see. So the reason why this assert is wrong is because this is wrong for one case, which is the last number. Because in the last number, everything is visited. So okay, so I made a mistake there. Okay, that's actually kind of good that everything else worked though. Yeah. Okay, this looks good, and I am happy. But yeah, so let's give it a some. Well, let's do one thingy case, and then maybe a two thingy case, and then the other one, but downwards. Yeah, let's give it a submit. But yeah, click on show gift because it always seems good to me, but I'm terrible sometimes. You could have wrong answer. Okay, cool. Yeah, so this is going to be linear time, linear space. Linear time because we look at each cell once or twice, I guess, but a constant number of times. We have constant, with linear space, well, two reasons. One is because we need it for the answer array, but we also use linear extra space in this visited matrix. So linear time, linear space, where linear is, of course, R times C again, because that's the size of the input that they give you, which is matrix. The other thing that I would say is that you can actually optimize this to constant. I said constant space earlier, but I still mean it, but I mean extra space because you can imagine this thing. You could treat, at least for this particular problem, it doesn't generalize as much, but for this particular problem, you can think about it as a bounding box, right? Where you just shrink its one row, one column, one row at a time, something like that. So you can actually represent this in all of one extra space. And there is more, you have to be careful more, which is why I didn't do it. But that's a direction to go. That's definitely a direction to optimize, and that's definitely some homework for you to kind of improve that at home. But yeah, okay. I think that's all I have for this one because I am going hiking soon. Follow me on Instagram if you want to check out check out my adventures. But so yeah, okay. Stay good, stay healthy, keep going. You're almost there. It's day 16. Uh, that's what people say at hiking too. You're like no matter how far you are from the end, and you see another hiker, they're supposed to tell you that you're close, so that you keep on going, even, especially when you're struggling. But of course, still know your limits. But that's another story. Anyway, stay good, stay healthy, to good mental health. I'll see you later, and take care.